At 2:43 hours on May 24, 2025, a silent storm descended upon occupied Zaporizhzhia Oblast. 3 Ukrainian strike drones, harbingers of destruction, pierced the darkness. Their target, a critical Russian logistics artery. Below, along the Vern-Takmak-Malachansk railway line, an 8-car train lumbered, carrying approximately 560 tons of fuel, enough to sustain 2 Russian battalions for an entire week. Unbeknownst to the Russian soldiers, this vital resource was about to become an inferno in the Ukrainian countryside. Denied to the war machine it was intended to fuel. This operation was a symphony of coordinated destruction, orchestrated by 5 distinct drones working in perfect harmony. Leading the charge was a DJI Mavic 3 reconnaissance drone, an eye in the sky providing overwatch and pinpointing targets from a distance of 8 kilometers. Following closely were 3 Ukrainian-built FPV quadcopters, the instruments of fiery justice destined to deliver the devastating strikes. A second DJI Mavic hung back, a reserve, a silent guardian, ready to step in should misfortune befall its brethren. These were not the drones of civilian hobbyists, purchased from online retailers. The DJI Mavic 3 reconnaissance platforms, field modified and hardened in Ukraine, were instruments of war. The stock Hasselblad L2D20C camera, boasting a 20 megapixel sensor and up to 28 times hybrid zoom, had undergone experimental firmware tweaks, reportedly extending the digital zoom to an astonishing 56 times. Select units had even been retrofitted with FLIR-Boson thermal cores, granting them the ability to conduct thermal reconnaissance and detect heat signatures under the cloak of night. Cruising at 68 kilometers per hour, these drones possessed a flight time of up to 46 minutes and could operate at altitudes reaching 6,000 meters above sea level. In stark contrast, the Ukrainian-built FPV attack quadcopters were purpose-built for one-way missions, instruments of self-sacrifice designed to deliver a single, devastating blow. Equipped with 7-inch propellers mounted on 2,807 class brushless motors, each capable of delivering up to 2.5 kilograms of thrust. These drones were tuned with F7 flight controllers running custom beta flight firmware. Reaching speeds exceeding 140 kilometers per hour in terminal dives, they maintained unwavering stability even during high-speed impacts, solidifying their position as one of the most effective low-cost strike solutions in modern warfare. 30 kilometers away, within the secure confines of a command center, Ukrainian drone operators watched the thermal feeds, their eyes locked on the emerging heat signature against the cool landscape. The DJI Mavic 3's thermal sensor, capable of detecting temperature differentials as small as 0.05 degrees Celsius at ranges of up to 200 meters, painted a vivid picture. This reconnaissance platform had been painstakingly modified with firmware designed to evade Russian aeroscope detection systems, which typically tracked DJI drones that transmitted unencrypted signals. Through encrypted communications, the lead reconnaissance operator confirmed visual contact with the fuel train. The thermal signature revealed the locomotive's diesel engine, a blazing beacon against the night, simplifying target identification even in complete darkness. All of this information streamed in real time to the strike zone operators nestled within the command bunker. The 3 FPV strike operators acknowledged the receipt of the targeting data through their encrypted communication system. Each Ukrainian-built one-way quadcopter was armed with a 2.6 kilogram shaped charge warhead, purpose-built for this singular destructive purpose. These warheads featured dual-stage detonation systems with hardened steel tungsten alloy shaped charges, capable of piercing through 22 millimeters of hardened steel, more than sufficient to breach the 10 to 15 millimeter walls of standard Russian fuel tank cars. The shaped charges focused explosive energy into concentrated jets traveling at over 30,000 feet per second, instantly penetrating the tank cars and igniting their contents with temperatures exceeding 2,500 degrees Celsius. The strike package included a critical yet often overlooked element: timing. Ukrainian intelligence had meticulously tracked this specific fuel train for 72 hours, leveraging a network of partisan spotters armed with simple smartphones. They had identified its refueling schedule, typical speed through this sector, and most importantly, the 15-minute window when it would be furthest from Russian air defense coverage. These partisans, ordinary civilians living under occupation and risking their lives if caught, continued to provide the targeting data data that made this precision strike possible. With the target confirmed both visually and electronically, the first strike operator initiated his attack sequence, guiding his Ukrainian-built attack quadcopter into a shallow dive toward the moving train. The drone's targeting system combined GPS navigation with terminal optical guidance for maximum precision. During each approach phase, the drone navigated using encrypted GPS signals. However, in the final 15 seconds before impact, the system switched to optical guidance, utilizing advanced image recognition algorithms. This dual-platform approach maximized mission effectiveness. The Mavic provided persistent surveillance and target designation from a safe distance, while the attack drones delivered precision strikes with minimal exposure time. However, actually hitting the train was far more complex than it appeared. The train covered roughly 11 meters every second, requiring perfect calculations. The attack drone's fixed-mount camera, equipped with digital stabilization, provided a real-time video feed to the pilot's goggles, maintaining visual contact with the target even as the quadcopter maneuvered through its final approach. The Russian fuel train continued its journey, oblivious to the fact that in less than 30 seconds it would be transformed into a raging inferno. At 0244 hours, as the first strike drone entered its terminal dive, the unexpected occurred. 3 kilometers away, a Russian Lear-3 electronic warfare system sprang to life, detecting the drone signals. This system, mounted on a Kamikaze truck chassis, carried jamming equipment capable of disrupting GPS signals and drone control frequencies across a 30-kilometer radius. It detected the commercial drone's telltale signal and unleashed a barrage of powerful jamming signals across multiple frequency bands, attempting to force the drones to crash or return to base, where they could be targeted by artillery. The drone operator reported heavy jamming on the primary frequency as his control interface began displaying connectivity warnings. The Lear-3 operators initially attempted broadband jamming, transmitting high-power noise across multiple frequency ranges simultaneously. When that failed, they switched to spot jamming, focusing intense interference on the specific 2.4 GHz band commonly used by commercial drone systems. But the Ukrainian operators had anticipated this very scenario. The Ukrainian system employed frequency hopping spread spectrum technology, rapidly changing frequencies hundreds of times per second across each frequency band. This rapid switching made it nearly impossible for Russian jammers to lock onto the signal. Both the DJI Mavic reconnaissance platforms and the attack drones employed this technique across 3 separate frequency bands simultaneously, a setup specifically developed for operations in heavily contested electromagnetic environments. The DJI Mavic reconnaissance drone continued to provide real-time intelligence through its advanced software, which automatically scanned for and switched to alternative frequencies when jammed. The reconnaissance platform's AI-enhanced sensors maintained target tracking even as communication with the attack drone became intermittent. The operator announced the switch to the secondary frequency as his attack drone system automatically hopped to the L-band backup channel. The primary data link distributed the signal across multiple frequencies, changing patterns up to 200 times per second, making it extremely difficult for Russian forces to detect or jam effectively. The Russian Lear-3 operators intensified their jamming efforts. Beyond simple GPS jamming, they attempted GPS spoofing, sending false satellite signals to trick the drone's navigation system. However, the Ukrainian drone's inertial measurement unit detected the inconsistency between the GPS data and its actual movement, automatically switching to backup navigation. Inside the drone's guidance computer, accelerometers and gyroscopes continued to measure every change in velocity and direction. This inertial measurement unit provided backup navigation that could not be jammed or spoofed. The combination of multiple guidance methods ensured the weapon would find its target even if Russian forces successfully jammed GPS signals. The operator reported GPS signal degradation while switching to inertial navigation as his attack drone continued to close on the train. Despite the electronic interference, the targeting system locked onto specific structural features of the tank car, utilizing image recognition to maintain precise aiming even as the train rocked on the tracks. The attack drone's onboard computer contained detailed target recognition algorithms trained specifically on Russian railway equipment. Even without constant operator input, the system could identify fuel tank cars, calculate optimal impact points, and execute the final attack sequence independently. The operator reported autonomous mode engagement as the drone entered the terminal phase. Though Russian electronic warfare systems had successfully jammed one channel, they could do little to stop what happened next. At precisely 02 2:44 hours and 30 seconds, the Ukrainian strike drone impacted the third fuel tanker car with devastating effect. The 2.6 kilogram shaped charge warhead detonated instantly on contact, its hardened steel tungsten alloy penetrator punching through the tank car's 12mm steel wall before the secondary incendiary charge ignited the pressurized diesel fuel within. The explosion ripped through the fuel tanker's interior at temperatures exceeding 2,500 degrees Celsius, instantly vaporizing hundreds of gallons of diesel fuel and creating a massive pressure wave that ruptured the tank car's containment systems. The strike operator confirmed a direct hit on Car 3 as he watched the explosion's heat bloom expand rapidly across his thermal feed through the DJI Mavic reconnaissance platform's cameras. The target was engulfed in flames, with secondary explosions in progress as the destruction cascaded immediately through adjacent cars. The fuel train's design, optimized for efficient transport, became its own worst enemy under combat conditions. The interconnected ventilation systems between adjacent tank cars, normally used to equalize pressure during loading operations, now provided the perfect channels for the fire to spread. Within 15 seconds of the initial impact, flames from the burning third car had ignited vapors in the second and fourth cars. The Russian locomotive engineer slammed on the emergency brakes. Now stationary, the train became a sitting duck as the next two drones swooped in to finish the job. At 02:45 hours, with the initial target fully engulfed in flames, the second and third strike zone operators began their coordinated follow-up attacks. The burning train was now easy prey. The second operator selected the sixth tank car in the formation, which remained intact despite the expanding fire from the initial strike point. His Ukrainian-built attack quadcopter approached from the southeast using the smoke and flames as concealment, while his thermal imaging system locked onto the cooler metal signature of the undamaged fuel tanker. The targeting computer compensated for the heat distortion caused by the burning cars, maintaining precision guidance despite the worsening visual conditions. The DJI Mavic reconnaissance drone continued to provide overwatch and target designation, with its AI-enhanced sensors automatically identifying and prioritizing the remaining intact targets. The reconnaissance platform's advanced thermal imaging system cut through the smoke and flames to maintain clear visibility of the entire target area. The operator reported engaging Car 6 as his attack drone entered its final dive. The shaped charge warhead struck with identical precision to the first attack, penetrating the tank car's wall and instantly igniting another 69 tons of diesel fuel. The explosion merged with the existing fire, creating a sustained inferno that now stretched across 4 consecutive tank cars simultaneously. The third operator targeted the rear of the formation, where 2 tank cars remained completely unaffected by the spreading fire. His approach vector brought the attack drone in from the west, striking the 8th and final car in the convoy. The impact triggered the same devastating sequence: penetration, ignition, and catastrophic fuel combustion that added another massive fireball to the growing inferno. The 3 precision strikes had now ignited approximately 560 tons of fuel, creating a fire that generated its own weather system. The intense heat created powerful convection currents that pulled air into the base of the fire and sent a column of smoke and flame over 200 meters into the night sky. The railway line itself had been rendered completely inoperable. The intense heat had warped the tracks into twisted metal. The wooden ties had burned through completely, and debris from the exploding tank cars littered the right-of-way. Russian repair crews would need weeks to restore this section of the railway, assuming they could work without the constant threat of additional Ukrainian strikes. The price of war is steep, and the battle space continues to evolve. As technology changes and the theater of operations becomes more complex, one must ask what the future holds for military tactics. This is Goba Military, and subscribe for more real-time battlefield breakdowns and tactical deep dives.